All right, what I'm going to do for the first day of class, the first day of actual lecturing, since we've already covered logistics of the class and we covered MyLab Plus. Now I'm going to start going through chapter 1 and 2. That's the reading. So if you're new to the class, you need to be reading chapter 1 and 2. Now what I'm going to do today is I'm going to go through chapters 1 and 2, and I'm going to pick out the things that you need to write down, you need to highlight, you need to, study for the test. Okay? So we'll go ahead and get started with that. If you've got a book, it kind of helps to follow along. Not just write the stuff that you need to write down. I'll give you the page numbers as well as the definition and all that good stuff. Now, statistics. What is statistics? When you hear the word probability and statistics, basically, statistics is the gathering and calculating and the interpretation of data. Okay? Data is what you're researching. Make sure you know what data is. So this is on page 5. Make sure you know what data is. Data is how many white cars are in the parking lot. That's data. How many trees are in the parking lot. That's data. Now, we don't know how many. We go out and look. We go out and count. That's the statistic part. Going out and counting, going out and getting the information. That's this right here. So there's 2 test questions, possible test questions right there. Now, these 2 guys, population and a sample, that's the 2 groups that we work with. This class, the 6 or 8 people that are here right now, if I asked you what's your favorite color, and y'all said blue, then I would say, okay, the sample said blue, so the average favorite color at the Anderson campus is blue, based on the sample. Because the population would be Anderson campus. Okay? They used you 8 people. Of course, you do that because 8 people is not a good enough sample for 400 or 500 of COVID. All right? So, population is usually your larger group, where the sample is usually your smaller group. Now, why would you want to do all the statistics and gathering of a smaller group versus a larger group? The 2 most important things in our life, and what are they? What are the 2 most important things in our lives? Time and what? Dollar signs. Money. Time and money. Is it easier to survey 30 people or 300? 30. So, a lot of times the sample is used to predict the population. Like that. 90% of the time or above, it's called a confidence interval. The sample is used to predict the population. So if I ask 8 of you if you're in the Marlboro Club or not, and 7 of you go, no, I'm not in the Marlboro Club, then I can go to the president and say 90% of Pendleton students, 90% of Tri-County Tech students are not in the Marlboro Club. That's basically what I just did. I used you as a sample to predict for all Tri-County Tech students. Now, that's when you get into the mathematics of is this feasible for 8 people to predict the whole population. And that's when we get into chapter 6, 7, and 8. This is chapter 1. All right? So make sure you know these 4 definitions. Data, statistics, population, and sample. Okay, wait for the question. What about census? Did I cover it? And you don't need to. Handies. Oh, what about census? What about census? If I don't cover it, chances are you don't need to worry about it. Census is something that's taken every 10 years. That's basically what it is. It's a gathering of data every 10 years across the United States. Okay? I don't think it fits in. It fits in with what this is, but it doesn't fit in with this group. I don't think it does. That's just my own opinion. I think it fits in as a sub-definition of that. That's just me. All right, so there's your first. Anytime you get one of these boxes in the book, make sure you kind of put one of those little plastic tabs on the page so you can go back over it right quick, because chances are if they're in one of these boxes, orange, yellow, manila boxes, chances are it's going to be on the test. And 4 out of 5 of these are going to be on the test. Okay? So that's the highlight. Let's see what else we're going to highlight. And that's basically what I do. I go through the whole chapters 1 and 2, and I tell you what's important. I don't go over the responses. That's for a research class. That's not for us. We're just studying how to get the data and what do we do with the data after we get it. We'll get all that in the research class. If you take classes at Clemson or wherever, they'll give you a research class, and then I'll tell you what kind of survey to use. Okay, correlation. Write down correlation. And write down correlation does not imply causation. In other words, correlation means that you can look at data and you can predict something from that data. Meaning, if 90%, if you look at the data and 90% of this, see a slant going down this way, then you can pretty much predict that you have a negative correlation. We're going to see some examples, but what I want you to do, I want you to be looking at that definition right there on causation. Look at that definition, find it out. It should have it on this page somewhere, probably on the next page, but that's fine. Probably have some examples too, and we'll look at the examples. That'll do more reviewing for you. They will, because I know there's pictures in here. We'll get back to the correlation in just a minute. Here's your mathematics in chapter 1. Real tough stuff. Okay. Most of you have had pre-algebra and introductory algebra, so I know you know this material. But I'm going to shout. This is on page 11. I'm going to go to a white page here. And we're going to talk about page 11 in mathematics. And this is just a review over percent, decimals, percents, and fractions. Fractions, decimals, and percent. Now, I don't spend a lot of time on this because I don't want to insult anybody's intelligence, but I am assuming that you all know how to do fractions, decimals, and percents. For those that haven't had pre-algebra in a long time, I'm going to cover a couple of things. A fraction is basically a ratio, 4 over ratio. And the best way to show a ratio. The best way to show a fraction is with a pizza. It's the best way. Everybody can relate to it. And that pizza has 8 slices, I think. I'm not a pizza cutter, so I don't know. My pizza I never did work with pizza. I just came over to get the joiner. Let's see, 1, 2, the stuffed crust joiner is good. 3, take some cheese and some mozzarella and take some extra pepperonis and put on them. They dang good. 4, 5, 6, 7, 8. Sorry about that one, guys. All right, so you got 8 pieces of pizza. If you eat 2 of those pieces, then you have eaten 2/8, or you've eaten what? 1/4. You've eaten a quarter of that pizza. And if you take your handy dandy highlighter, not that big, and if you shade those 2 pieces in, what does that mauve piece look like? A quarter. Okay. And that's a fraction. So I'm not going to go into fractions too much, except for what kind of fractions are there. There's improper and proper. Improper is top heavy. And proper is bottom heavy. What is a mixed number? A mixed number is only used for units of measurements. It's not even a fraction. I guess you could call it a fraction. But a mixed number is only used when you got feet, inches, pounds, cups. That's the only time you use a mixed number. Think about it. You don't walk into Walmart and ask for 25/3 feet of rope. You ask for 6.5 feet or 7.5 feet. That's what you change it into a mixed number. So mixed numbers are only used for units of measurement. Okay? Always, what is the always rule for fractions? Always what? Always reduce. You don't walk into Walmart and ask for a 50/100 wrench. You can, and you can watch a guy go ask 15 different people, which I've done. They don't make a 50/100 wrench. 50/100 is what? 1/2 inch. That's right. They make a 1/2 inch wrench. They don't make a 50/100. They don't make a 3/6 inch wrench. They make a 1/2 inch wrench. Okay? Because it's the same number. It's the same fraction. It's the same number. Same mathematical value. So that's fractions. Decimals. Decimals are another way to write fraction. Another way to write a fraction. And the best way to show you is with something over 10. Because the decimal values, here's the decimal. What's this first decimal value right there? That's the 10th place. And what's beside it? 100th, and so on. So anytime you can put the denominator as a base of 10, it makes life a whole lot easier. So if I want to write 4/10, 4 over 10 as a decimal, 4 over 10 means 4/10, which would be what? 0.4. And that's how you do it if it's got a 10 or 100 or 1,000 or 10,000 or whatever. Just put the numerator in the decimal point. But what if you don't? Well, what if you have 2/5? Or let's say 3/5? Well, there's 2 ways to do this. One is you can change that into a 10th, and 5 will go into 10 how many times? 2 times, Hubert. Good class. 2 times 3 is what? And 6 over 10 is? So that's one way to do it. Or you can do it the old mathematical way, just divide it. Divide 5 into 3. Well, it won't go into 3, so you add a 0 to it. And how many times will 5 go into 30?
6.
It's a miracle. You got the same answer. So you can do it this way, or you can do it this way. Now, why can you not do it this way all the time? Because 3 won't go into 10. It will, but it will be decimal. So you have to rely on the division to change into a decimal. Okay? So, basically, what we're talking about, fractions, decimals, and percents, is 3 ways to write a ratio. Or a ratio. Percent. Percentage. What does centus mean? Well, cent, centipede, century. What does centus mean? Centipede, century, cent, as in penny. Huh? No. How many pennies are in a dollar? 100. So century, centipede, cent, centus means what? I can't get nothing by y'all. Okay? And what does per mean? Miles per hour. When you hear the word per in mathematics, it's not the same on cat names. Per. Miles per hour. What does that per mean? Huh? Yes, but what? There's 4 mathematical operations: addition, subtraction, multiplication, and division. What does the per mean? Yeah, which one is it? I just asked you. Which one is that? Is per? It's division. Per, because it's miles per what? Hour. So per means divide, right? So somebody tell me what percent means. What does percent mean? There you go. Percentage. Percent means divided by 100. So if I give you 26%, that's equal to 26 over what? And then I made a fraction, or I can make it a percent, make it a decimal by saying what? There you go. There you got it. So you can rewrite a fraction as a decimal, decimal as a fraction, fraction as a percent as a decimal, blah, 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 blah. So if I give you 33%, then you put it over 100, and you can write it as 33, or you can write it as 32 over 100. Now, can I reduce this down if I left it a fraction? Let's say we didn't do this. Say the directions say, leave it as a fraction. What would I do with this fraction? 13 over 50, good. If it says leave it as a fraction, then you need to reduce it all the way down. If it says write it as a decimal, you want to leave it over 10, 100, or 1,000. Well, 100 in this case because it's percent. And that's your mathematics in chapter 1. Okay? Everybody feel good about themselves? So I can knock you down later. Where's my book? I lost my book. I lost my book. There it is. Alright, so that's on page 11. Make sure you know how to do that, because that's a test question. Okay. That's a test question. Now, it may not be, we're talking, so far I've got about 5 questions to pull from. I told you that chapter 1 and chapter 2 was probably 20% of your test. So if I give you 20 questions, that's 4 questions. Okay? We've already went over about 6 questions so far, and 4. So that could be one. See, I'm going to put like 8 to 10 questions in a pool, and when you get to that question, it's going to pick from 6 to 8 questions. It's going to pick from that. this is one of the possible questions right here. Changing from this to this, or this to this, or this to this, whatever the case may be. Okay? So definitions, got 4 or 5 definitions. Then we got this. We're moving on. We will go back to correlation before chapter 3 is over with. So just bear with me. I thought we could. We've been reviewing another book, and I think I've had it mixed up with another book. I think this is homework in the book. If I pass this. No, it's not. Is it? Yeah, 1.2, or is 1.2 still on this page? Nope. I guess we're in 1.2. Whatever. Go away. Thank you. Now, these are homework questions. Heck, wrong. See, 1.3
starts at the bottom.
Okay, 1.3 starts. We want to talk about sampling population. Okay. Ding ding. Write these two down. If you would have wrote one of them down, they didn't. Statistics is one of those words that has 2 definitions. Okay? The first definition usually is with a capital S. Is when it is talking about getting the world of getting data, obtaining data, calculating data, interpreting data. That's capital S. If you see a lowercase s like this, that means a numerical measurement describing some characteristics of a sample. Okay, just forget that. Let me show you what a sample and a parameter is. I told y'all a while ago that the big group is called what?
The population.
The population. So in this case, we're going to use Tri-County Tech students. That means the students at the Easley campus, the students at the Anderson campus, the Oconee campus that they're building, or the Career Center in Williamston, all the different little campuses we've got all over the place. That's all. If you are paying Tri-County Tech for a class, you are a Tri-County Tech student. That could be 5 or 6 different places around the 3-county area. Right? So that means any formulas, any variables we're going to use, variables are what? Letters, right? Algebra, letters, A, B, C, D. Most of y'all deal with X, with algebra, X. Well, the variables with the population, we're not going to call them variables, we're going to call them parameters. Remember, PP, parameters, population. We're not going to use variable. We're not going to use the word variable because that's too algebraic. We're going to use parameters. Now the parameters are always going to be Greek letters. The ones you're going to see the most of in this class is mu and sigma. You don't think this is funny when I tell you why we're learning this. But now, what is the smaller group? Sample. And we're going to say Hubert's 102 students. No, I'm sorry, 120. That could be 3 classes. The onlines that are watching and this class. Of course, this is a smaller group than this. Now, we're not going to use variables with this group either. Variables is algebra. We're not going to use that word. We're going to use statistic with a little s. And these variables that are called statistics, okay, they're not variables, we don't call them variables. They're going to be just regular letters. And the ones you're going to see most of is X bar and S. They both mean the same thing as mu and standard deviation. I'm sorry. Average mu and sigma. Mu and X bar are the mean. Sigma and S is the standard deviation. Well, then why you got to put them two separate? Context. What does context mean? Like context clues in algebra. Context clues in English. What do they mean? What the word means, right? For example, if I said something about so, well, so has three definitions. What's the three definitions of so? Needle and thread, that means so, S-E-W. What's another definition of so? Grass seed. Well, come on, I'm expecting everybody to know that. Usually nobody knows that. I don't know. Usually that's another part of me that says it's your parents' fault. But you messed that up. What's the third definition of so? Spelled different. S-O, like so. So if I just say so, I could be three definitions, but if I said so a darn means what? Needle and thread. Darn is sock. Okay, so if you're in a meeting, let's say you're in a meeting, let's say it's 10 years from now and you're working for Michelin or you're working for Floor Daniel, or you're in a meeting, next student tie meeting, board meeting, whatever, and some whippersnapper does a PowerPoint, he throws up there these two guys. And you know it's going to have to do with what? Population. But if he throws up these two guys on the PowerPoint, you know it's what? It's the same. And therefore you don't sound ignorant when he says, you know, this is the sample, this is the population. So the only reason you use these as parameters, mu and sigma, they mean the same thing as these two guys, is to know what the context of using it. That's why you learn.
Do you just pick which one you want to use?
No. In other words, if you're dealing with, if I want to do the average age of people in this classroom, then the average would be X bar, and the standard deviation would be S. But if I did Tri-County Tech, it would be mu and sigma. And I'm telling the person reading the information, I'm telling them this is the population without saying population on the top. When they're reading the information, if they know anything about statistics, they know that if they see these two guys, that I'm dealing with the population. If I put these two guys on there, I'm dealing with the sample.
Do you think which one you want to use in like
No. And the question will say, this is a population, sigma is blah, blah, blah. It's gonna, they go together. You don't interchange them. You don't use S with the population. The question will say it, the question will say it, or you know it, one of the two. I mean, it's gonna, we don't have to deal with it that much. In other words, the question will say the population is blah, 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 find the mean and standard deviation. And when you write down the mean on your paper, you go mu. Standard deviation is sigma. If the question asks you to put the whole thing in and you put S, it's going to come wrong. Because the question is for population. Okay? Yeah. So most of the time, if the question does not say, it's going to be the sample, because most of the time in statistics we're dealing with sample because we don't want to have to deal with what? Population. So most of the time it's going to be this. You'd be surprised at how many people don't know that that's the only reason these are explained is for context, like in a meeting or in a problem, and I just give you a sheet of paper with my work on it, and if you see sigma, then you know it's with population, and if you see S, you know it's with seconds. That's the only reason we teach that. Okay? So this gives you an idea that you're dealing with what? That. And this gives you an idea that you're dealing with that. And these two guys are called statistics with a little s. And these two guys are called what? Parameters. Parameter, population, sample, statistic. And that just gives context. Basically, that's all that does. You ever played 6 Degrees of Separation with Kevin Bacon? Y'all have no idea what that is. It's your parents' fault. I'm just kidding. As a game, you have to read it right here. It says it right here. It started a long time ago with some other game, but the people started doing it with Kevin Bacon. Who's Kevin Bacon? He founded Bacon. No. Who's Kevin Bacon? He's a movie. He's an actor. Okay? And he's just about played in everything. And one of the games is 6 Degrees of Separation. You're supposed to name an actress or an actor or a movie. And in 6 steps or less, you can type Kevin Bacon. I'm not good at it. I suck at it. I love movies. I'd rather watch a movie than sports. But I'm not just taking it. I'd much rather watch a movie. Especially what's that good to me. Alright? But name an actor or an actress or movie. Who? Taken. God, I suck at this. Okay, I only know one person in Taken, and that's Liam Neeson. Whatever his name is. Liam Neeson played in all the Taken movies, but he also played in a movie with Ross Pearson. About these two Confederate Civil War people that went after each other. Pierce Brosnan. What's his name? He played a 007. Pierce Brosnan. I think that was his name. But anyway, Pierce Brosnan played in 007. 007 was also played by Sean Connery. Sean Connery played in Hunt for Red October. And Hunt for Red October was about the Department of the Navy. And Kevin Bacon played a Marine for the Department of the Navy. And a few of them. I suck at it. There's a whole lot better people that can do it than us than that. But it's just basically what? It's probability of finding something in common with somebody else. Just like one of the reasons I give y'all my information sheet is because a long time ago I got y'all to fill out an index card and I put 6 categories on board. And y'all would fill in 6 categories. One was favorite color, one was the day, month you were born, one is where did you go to high school, the other one is are you married, and do you have kids? And you would fill those 5 things out. Or your favorite movie, or I would just do different things. And I would pass the cards out. You would write those things down according to you. And then I would take them up and I would pass them out where you didn't have yours, but you had somebody else. And we would read them out loud, and no names, and you try to figure out who was the person that wrote down the things. And the whole purpose of the little exercise is to show that everybody has something in common. Whether it's a favorite color, whether it's your birthday, same month, whether you went to the same high school, everybody has something in common. Whether we all have brown eyes. Brown eyes are best color. That's what you believe. All right. Kevin Bacon, try another one. That was a hard one. But there's nobody in taking except Liam Neeson. He's the only star.
That's why his face not
Pierce Brosnan. Y'all know who I'm talking about?
The guy who plays in Footloose, right?
No, that's Kevin Bacon.
Yeah, that's funny.
Pierce Brosnan is the guy that played in 007. He's a black-headed guy. He's got a British accent.
Yeah, he also plays the lion in
Yeah.
whatever the name of
He's played in a lot of other movies, but he played opposite of Liam Neeson. Liam Neeson was a Confederate soldier, officer, and he was chasing Pierce Brosnan. Pierce Brosnan was a Union soldier, and he was chasing him with war crimes. The whole movie was like him chasing each other. It was a good movie. But anyway, he played in that. Pierce Brosnan, 007 played Sean Connery. Sean Connery played in the 60s. And Sean Connery played in Hunt for Red October, which was about the Department of the Navy. And Kevin Bacon was an employee of the Department of the Navy because he played a Marine in two different Marine Jag. So name, give me an actress. Sandra Bullock. Trying to think of some good movies. I know that. I'm trying to think of Kevin Bacon. Sandra Bullock played in a movie with Keanu Reeves. What was it called? Speed. Right? Keanu Reeves played in The Matrix. Okay? The Matrix, which involved Lawrence Fishburne. Right? And then Lawrence Fishburne played in The Matrix, but he also played, that was the other guy. So that's something. You have to play it a lot to get at. I'll have to let's see if we can find something on the web about it. I think it's an interesting game. I just don't ever get to play it. As you can tell, I suck at it. So you can go on Google. Six degrees separation. Kevin Bacon. Let's see, Kevin Bacon and Sandra Bullock. You just have to look it up. Sandra Bullock. Then there it is. Dennis Hopper. I knew it was Speed somewhere. Dennis Hopper played in Speed, and Dennis Hopper played in movie with what you call it. But anyway, here we go. Where'd it go? There we go. No, not that one. Dennis Hopper. Where'd it go? Well, here's one. Sandra Bullock played with Nicole Kidman in Practical Magic. Y'all know where the two sisters are. That was a good movie. The two sisters are witches. And Nicole Kidman played with Tom Cruise. Tom Cruise played with Rob Lowe in The Outsiders. Rob Lowe played with Sally Fields, brother and sisters. Sally Fields played with Julia Roberts in Steel Magnolias.
and that. And Julia and Kevin in Sleepers, which was a horror movie. You got to know your movies too. Natalie Portman, I don't know what this, that's somebody else. I was wanting to see, but this is a whole page of Kevin Bacon. I was wanting to see Sandra Bullock. Why can't I? I don't know why it's not showing that
It's
one.
probably like down
There it is. Audrey Hepburn to Kevin Bacon. Judy Garland. Mickey, no, that's way over my head. But it's just, like I said, it's a game you play, and I don't know if you want to play it or not, but it's all about probabilities, all about it. I thought they had a database where you could put just one name in it and it would play it, but you put the word in the little box like Sandra Bullock, and it would put the 6 degrees of separation. But oh well. Okay, let's see if you can do this one. Brad Pitt. Brad Pitt played with Thelma Louise with Gina Davis, who played The League of Their Own with Tom Hanks, who played Apollo 13 with Tom Hanks. With Kevin Bacon. So you could do those all day long. Can't believe y'all never heard of it before. It's your parents' fault. All right, now you remember it. We talked about parameter and statistic. Okay, write this one down. This is a test question. Quantitative versus qualitative.
Why do they call it category?
Because they're trying to confuse you. What's the old saying? Quality instead of what? Quantity. And that's what this is. Quality is how something is made. Quantity is how much of it's made. Quantity is numbers. Quality is not numbers. So blondes, brunettes, and redheads in the classroom. That would be qualitative. Average weights, average heights, average ages, that would be quantitative, because it has to do with numbers. That's pretty self-explanatory. Okay? I'm not going to spend a lot of time on that, but that is a test question, so make sure you know it. There's quantitative data, age. Quantitative political party. That's quantitative. Okay, let's talk about discrete and continuous. Now, the reason I want to talk about this is an important question, and it's one of the easiest questions on your test, but y'all get it wrong. And I don't know how to fix it. I've tried to explain it the easiest way that I can, but most of the time people miss it because I wasn't in class the day I went over the lecture. That's most of the, one guy last semester missed it on the final exam. I said, you don't remember us talking about the tree? Duh. So, let's talk about it. Now, in order to talk about discrete and continuous, I got to go back to high school and go over something else you didn't know anything about. Continuous is like your irrational numbers. And discrete is like irrational. Now, if I was to ask you what your irrational and rational number was back in high school, you'd all sit there and go, well, most people would go, oh, yes, irrational is not predictable, rational is predictable. If I give you some numbers like this, square root of 7, square root of 2, get your calculators out, and pi. Get your calculators out and tell me what those three numbers are. I'll write them down for you. Square root of 7. And I want all 10 digits. I think most of your calculators go to 10 digits. What's the square root of 7? Go slow. Now, I ain't no. I can't.
2.64575131.
Okay, somebody take the square root of 2. Give that to me.
141421356.
And what is pi? And keep going. I want to know the whole thing.
2654.
Right here. 2,
It's
6,
actually 92.
9, 2.
And then 654.
Hold on. Let me just read through. 3 point what? 1, 4.
1592654.
Really? Okay. Well,
Touch that thing up there.
there's something wrong with this system. It's always done it before. I have to write with the mouse now. Oh, now it's unstuck. Thank you. It's a joke. 3.15. Now let's see if it'll work now. Now that I've unstuck it. 1, 5.
9.
Let me try one more thing. Nope, it's dead. 1, 5, 9, 2, 6, 5, 4. Alright. I want everybody to look at this blank. Here, here, and here, and tell me what the next number is on all three of those numbers. Can you tell me? Why? Why can't you tell me what the next number is? There's no what? There's no pattern. Does everybody see that? There's no pattern. There's no predictability. It's all over the place. Think of another word. All over the place. It varies. In other words, you cannot predict this next digit based on what you see here. So it's ambiguous. Rational. All right, punch these in. You don't have to because they're pretty easy. Okay, what's 1/2? Can you tell me what that next digit is? 0. How about 2/3? So you can tell me what that next digit is? and 4 over 2. And you can tell me what the next digit is. So, do you have predictability with rational numbers? Is it more solid? Okay, so discrete means solid. Continuous means not solid, means not predictable. And it still won't tell us nothing new. Let me give you an example. Let's say that I brought in a box of measuring devices. Some of them were tapes you pull, like a tape measure a builder uses. Some are range finders where you shoot it to that wall and shoot it through a beam back. Some of them are just cloth tapes. Some of them are yardsticks. Some of them are the old. You ever seen old carpenter's ruler that flips? The old wooden carpenter's ruler. Okay, well, some of them it's a ruler. Okay, and I tell each one of y'all to come up here, pick the out of the box, pick the whatever device you want to use, and you don't have to look, but there's a fire hydrant right down there. Right there beside the sidewalk. Okay? And I tell each one of you to go down there and measure that fire hydrant. The height of that fire hydrant. How many of you would agree on the same height? Y'all would give me 8 different measurements. Why? Well, 3 of you out of 8 don't know how to read measuring device. Don't know how to read a ruler. Because that's about a third. A third of the students graduate high school, you don't know how to read a ruler. Alright, so you just say 7, you'd say 27 inches. You wouldn't give me the fraction. So 3 of you would give me 27 inches. Okay, what about the other 6 or 7 or 5? What would y'all do? Well, 3 of you would read the little marks, and you would read, one of you would read big mark, one of you would read the little mark, the other one would go down or round up. So there would be 3 different measurements there. What about the other 2? Well, the other 2 would dig down under those people that already measured, they just went from the mulch. You just held down to the mulch. Well, 2 of you said it's at the height of the fire hydrant. So you took your foot, moved the dirt away until you get to the bottom, and instead of 27 and a half and 27 and 27, you got 28 and a quarter, and the other person got 28 and a half because of different readings. So you would each give me pretty much a different reading based on the measurement, based on what you thought the measurement needed to be, or what you thought, or how you read the actual measurement. So, what word did I use with all of that measurement? I can't remember the word. Measurement. So anything measured is going to be what? Continuous. It's very difficult to write with a mouse. Now tell me what's measured. Height, weight, width, length, volume. Get the point? Anything having to do with measurements is continuous, because you might read 2 3/4 cups. You may read 2 1/2 cups. You can't be exact. Unless they come out with some machine that will only put out 2 1/2 cups of milk. And then it would be, would you get the same amount? Even machines have a mistake, because sometimes you get M&Ms. Sometimes you get more red ones than you get green ones.
Sometimes you go around and you get this supposed to be for now. But you got to get that.
Then what does that leave with these guys? Well, let me give you another example. Let's say that we shut that gate up there and we shut this gate back here, and there's no way to get on this campus unless you ride through the trees or through the field. And I tell you to go out and count the number of four-door cars in the parking lot. I didn't say four-door SUVs. Did I say four-door truck? My truck is a four-door truck, but that don't count because it's my car. I'm talking about a four-door car. And I asked you to count. Would y'all give me the same? Would you give me the same numbers? Yeah, because all of us know how to count, right? And there's no ambiguity in 10 and 10. So what would counting be? There you go. See how easy it is? See if it's working. And that would be a no. I get so sick of this. And see, if I stop, it'll erase my recording. So counting, anything that you count, eggs, cars, redheads, brunettes, brown eyes, Marlboro Club, anything counted is discrete. Anything measured is continuous. And some of the questions they ask you on the test is just gimmes. The height of a tree, what is that? Continuous. It says height. The number of eggs in a carton, counted. Because it's what? Number of eggs. So you need to write that down. You need to put height, weight, length, width, volume, all things measured here. Counted. Eggs, cars. What else do we count? I can't think. M&M's, Skittles in a bag. If I put a bag of Skittles in here and ask each one of you to count the number of Skittles in that bag, y'all would give me the same answer. Unless somebody ate one. That's the difference between the Skittles. Now, if you want to use those definitions, go right ahead. Okay? And you feel good about yourself. Not sure what time it is. I don't want to keep y'all. Oh, we here at 2:30, ain't we? We got plenty of time. 2:15. You got to remind me, 2:15. I got to pick up my son today because I get him an extra day this week. Instead of, I don't have him this week, so I get to pick him up this week. One day. Okay, now we're not, are we, okay, now we're locked on page 17. Okay, this is good. I'm not going to do anything. Yeah, I got all kinds of things running up here. Probably gonna blow up. Come on, you can do it. Let's just get out of this. Probably logged me out. I love these things that log you out while you're using it. Okay. Bush's fault. Oh, heck with this. Y'all get on to My Labs Plus, okay? Okay, thank you for your interaction. Appreciate that. It's always nice to have a class to speak to me. What is up with this computer? Okay, I'll type half of what you put in. It's just one of those days when shit can get up. Y'all sabotaged my computer during the break, didn't you? Y'all came in here and messed it up. Okay, nothing. Okay, it's like it just don't want to come up. What's the deal? Is the internet down or what? Y'all aren't going to talk to me. I don't know why I'm asking that. Let me use Google. Did y'all just see that? All them things just went white. Let's see if it'll at least go to, okay. That means that the internet's working. Let's see if the internet is working. Y'all settle down. There we go. We're back in business. Sorry about that. Sorry. I know y'all was hoping that it would fall apart, but I'm sorry. Now it took me a half hour to get back. Where was I? 1 point what? Was it 1 point? What page?
17.
Thank you. We were trying, yeah, until it locked everything down. Okay, the only thing I'm going to give you on levels of measurement is study 18, 19, and 20. But on the end of that, right here, you can just on the page, on back of page 20, just go over it right here. Levels of measurement, a ratio, heights, lengths, distances. So ratios are what? Are continuous because it's heights, lengths, distances, volumes. What is that? Things that are what? Measured. Interval, that's body temperature, like a thermometer. Yeah, well, they don't ask if it's continuous. I was just telling you that this one is. The interval level of measurement means that it has intervals. Like if you get a thermometer, it's base 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And usually a thermometer goes up to what, 150? Because you dead by then. If you get up to 150, you dead. Because we only get up to 102. Alright, so it's got intervals. 10 interval sections. Kind of like a ruler. A ruler would be intervals. Because it's every inch. Ordinal. What's the first three letters of ordinal? Order, ordinal. They have to be in order. Rank, place, order. Rank, place, order. He came in first, second, and third. That's place. That would be ordinal. Ranks of colleges, ordinal. Anything in order would be ordinal. And nominal would be pretty much any of these. So, eye color. So, only thing I want you to know is the level of measurement and maybe an example. I don't usually put those on the test anyway. But that's on page 20. Make sure you know the difference between observational study and experiment. An observational study is where you just what? Watch it. You ever seen these videos of people with sleep apnea when they videotape them while they're sleeping? That's the observational study. I don't want to watch myself when I sleep. Don't tell them what kind of faces you make. And then they got all these wires hanging off your head. But that's an observational. In other words, you're watching somebody sleep. Now, what if I shocked them every 5 seconds with a cattle prod? Would that be observational or would that be experimental? When you start influencing the observation, that becomes experimental. When you have something to do with the outcome, that's experimental. What about there's 8 of y'all in here, giving 4 of you a blue pill and giving 4 of you a red pill and secretly telling the people that took the red pill that they're going to lose all kind of weight in the next month. They take that pill every day. But I don't tell the people with blue pill anything. They're both sugar pills. Yeah, and they're going to get it in their mind. They're going to watch what they eat, and they're going to quit eating, and they're going to lose weight. All right? Is that experimental or observational? Because I had something to do with it. Okay? That's the difference between the two. That's a test question. Because it's simple. I try to put simple ones on there. I want you to know what a random sample is. I do not care about a random. Okay, here it is. Random sample. This is on page 25. The key word with random sample is right here. What does that say? Each member of the population has an equal chance. No yawning in class. No coughing, yawning, or breathing. Y'all settle down. Each member of the population has an equal chance of being picked. Right now, y'all don't have an equal chance of being picked. But if I put each of your names on a piece of paper, like a raffle ticket, you ever seen one of those little tickets you get with a number on it? I turn it over on the back, put your name on it, and put it in a hat, put it in that box right there, shake up the box, and have one of you pick one ticket out. Is that a random sample? Yes, because everybody has the same chance. What if I folded one of the tickets and all the other ones were not folded? That would not be a random sample because the feel of that other ticket would pull the drawer to maybe pull that ticket instead of another ticket subconsciously. So it kind of messes it up, but everything's got to be uniform. So I want you to know random sample. That is a test question. Not simple random. I don't do simple random. Random sample. What is a systematic sample? Systematic sample, keyword. Well, I don't see a keyword here, but every. In other words, every 5th person, every 8th person, every 100th person in the phone book you're going to call. That is a systematic because there is a what? System. There's a pattern. Every 5th person that walks out of the front doors, I'm going to ask them if they're in the Marlboro Club. That's systematic because I'm asking every 5th person. It's a pain to keep up with, but it's systematic. These are pretty. These are good. These are good. This ain't good. Why is convenient sample not good? It's easy. Exactly. It'd be like me asking the people, let's say that I worked at a rock radio station and I wanted to find out how many of the listeners like rock music. Call in right now and tell me if you like rock music or not. Yeah, they probably like it if they're listening to it. So that would be a convenient sample. It's not reliable. So that one is, just know what it is, but no, it's not reliable. It's the least reliable. Stratified and cluster sampling. Stratified would be like Republicans and Democrats. In other words, they're grouped among two different groups. Now, what's the difference between stratified and cluster? Cluster would be in the sections like courses. Like I could teach, out of all the Math 120 courses, I teach how many? 3. So that would be a cluster. My 3 Math 120 classes, the 2 online classes in this class, would be a cluster. So I would take all them students and ask them a question. That would be a cluster sample. Because I've got a cluster of, they're not Republicans or Democrats. I'm not asking them that. They're just all my Math 120 students. Okay? That's a test question. Those 5 things that I just went over, that's a test question. And that's some more of it right there. I'm not going to go over it twice. Make sure you know what retrospective, cross-sectional, and prospective studies are. What does retro mean? Huh? Retro means go back in time. If you dress retro, that means you're going back to a certain decade and you're dressing like that. Please don't go back to the 60s or the 70s. I don't know about the 80s either. Parachute pants and big hair. But we had the best music. The 80s had the best music besides the 60s. 60s had real good music, but the 80s had the best music, in my opinion. What is cross-sectional? Data are measured at one point in time. Just remember, one point in time. The test question will read 1 point in time. It might have something else, but it'll say 1 point in time. That's cross-sectional. And prospective predicts, goes forward in time. That's pretty simple. That's why I put it on the test. They're pretty simple. So far, I'm on page 30, 31. Couldn't see, I think that's 1.4, is it not? Syllabus says we go to chapter 2 now, right? What page is chapter 2 on? Anybody know? I'll just go back. Huh? Oh, there it is. Okay. Okay, make sure you write down what's on page 44 in the middle of the page. Center, variation, distribution, outliers. I'm not worried about time. Everybody knows what time is. It's what we live by. And it does not what? It doesn't slow down, and it doesn't what? It doesn't get fast. It seems like it gets fast. But the only thing constant is time. Center. Middle of the data set. Variation. Data values vary. Distribution. The shape of the spread. And that's all you need to write. Shape of the spread. Outliers. That's your 6-foot second graders. 300-pound third graders. The ones that are way out there. Make sure you know those definitions. Okay, here we go. We're starting to get into a little bit of math in chapter 3, in chapter 2. We're starting to get a little bit. Now, not very complex, but we're starting to get into things that's going to be used in chapter 3. The first thing is a frequency distribution. A frequency distribution is a 25-cent word for a chart or a table. if you'll look, I'm putting a frequency distribution up here right now. That's all it is. It's a head count. All right, brown, blue, green, and hazel. What color are your eyes? Hazel. What color are your eyes? Brown? Like me, brown. Color brown? Brown? Okay, my vision's getting bad. I would say brown. Miss Cowart, I have no idea. Hazel? Blue? Brown. And you'd have a frequency distribution. That's all the frequency distribution is. Why can't they just call it a table? Frequency distribution. You have classes on the left. You have head count on the right. Please don't make this more difficult than it is. It's not. It's not difficult at all. Frequency distribution. Got to make it sound good. All right. Now we're fixing to get into a little bit of math. Write those down. Just write down the names. It's on page 45. And I want you to write down the names. And then what I want you to do is beside the names, I want you to write down how to get it. I don't want you to write down the definition. I won't tell you what to write. Just write down lower class limit, upper class limit, class boundaries, class midpoints, class width. And we're going to use this example right here on the right hand side right there. We're going to use this example. So just write these definitions right here and then put this table right beside it on your paper, because that's what we're going to use as an example. Because the best way to do this is to not give you any definitions, but to just show you and then look over the definitions. I better take the roll. And I'm going to have to use so what are your lower class limits? I'm going to take my handy dandy highlighter and I'm going to highlight. I can't use yellow because it'll. You ready? Your lower class limits are right here. Pretty simple, isn't it? Now let's see how smart you are. If that's the upper class limit, and what do you think? I mean, if that's the lower class limit, what do you think the upper class limit is? The other side. Good job. We're going to skip. So we're going to skip. We're going to skip class boundaries. I'm going to cover it last. Okay, midpoint. I'm going to go over here and I'm going to put midpoint. Can't spell. Is equal to parentheses upper class limit plus lower class limit divided by 2. Write that down. So somebody give me the first midpoint. It'd be 50 plus 69.5 and whatever you say. What'd you say? 59.5 would be your first midpoint. Now don't calculate anymore because there's no reason to. I'll show you why. Because your best friend, let me highlight this and let's highlight this blue. Find your first midpoint, 59.5. Your best friend, and we'll color him green, is this guy, the class width. Now, how do you get the class width? Well, you take your pick. You take a lower class limit of the second class minus the lower class limit of the first class, or the upper class limit of the second class. I'm going to just put some examples right here for the class width. You're going to get the same thing. Class width is equal to 89 minus 69. Or it could be 70 minus 50. Or it could be 130 minus 110. Or it could be 149 minus 129. And what are the answers to all of those? 20. Now, where did I get those numbers? These two guys, the first two, 89 minus 69. 89 minus 69. 70 minus 50. 130 minus 110. 149 minus 129. I just picked two class limits and subtracted them. Now, can I go 149 minus 70? No. They have to be continuous. Now, another way you can do it is this way, but I don't teach this way because if people take 69, if people take 59 from 69, 50 from 69, they come up with 19. And that's not the way to do it. You also have to include 50, which gives you 20. And people forget to do that, so I'm just trying to show you. Alright? So 89 minus 69, 70 minus 50, 90 minus 70, 109 minus 89, 129 minus 109, 110 minus 90, 130 minus 110, or 149 minus 129. The answer is 20. The class width is 20. Now, the good thing about the class width is once you get the class width, you can figure all your other things by just adding the class width. Let me show you. A while ago, you said the midpoint for the first one right here. Let me see if I can do this. Put this right here. Was 59.5. Now, instead of calculating all the other ones, all you got to do is add what? Add 20. So what's 20 plus 59? 79.5. What's 79.5 plus 20? And so on. 99 plus 20, I have no idea. 119.5. And 139.5. Thank you. Now, people, that ain't hard. And that's your class width. Now, the only thing left is the class boundary. Now, before I do the class boundary, I need to make a note about something because it's going to get you on the test if I don't make a note about it. So, appreciate it. That's not the right color. No, I'm sorry, that goes right here. I might as well just quit. I do all this for y'all and one other thing. Okay, now the class width, I'm going to put some rules over here for you. When you're doing the class width, if your values are whole, your class boundary is going to be to the tenths. If your values are to the tenth, your class boundary is going to be to the what? One more digit, hundredth. Class boundary is going to be to the hundredth. And one more, and you can get the pattern. If your class boundary, if your ... is to the hundredth, your class boundary is going to go to the what? The thousandth. Everybody see the pattern? Now you need to remember that because, and usually if you go to the tenths, it's going to be 0.5. If you go to the hundredth, it's going to be 0.95. And the thousandth is like 0.095 or something like that. Well, I made it small so I could hold on. Y'all just ain't never satisfied. We're just about ready to give up, y'all. Can't make it bigger. Hello? Thank you. Picky, picky, picky. Lord. There we go. How's that? That better? So in this case, and the problem that we're doing right now, and I'm going to color this in, I don't know, orange. In this case, we have what? What is our values? Whole numbers, tenths, or hundredths? Whole numbers. So our class boundary is going to be to the tenth. So what's right before 50? 49 point what? 49.5. So your 49.5 is going to be the class boundary here. And now we just add what? Class width, Hubert. That's right. Or you can go down. You can do that. 49.5 plus 20 is what? 69.5. 69.5 plus 20 is what? 89.5, 109.5, 129.5. And then go over here. All right, 69.5 plus 20 is what? 89.5 plus 20 is what? 109.5, 129.5, and 149.5. So, tell me what the class width helps us with. Did I move this thing again? I think I did. The class width will help you. Oh, good gracious. I'm about ready to quit. I'm going to draw a line right here. The class width will help us with the class midpoints. And it'll help us with what else? Class boundaries. Yeah. So don't do the class boundary and the class midpoints by doing all the math for each little class. Just do the first one and then you can just add the class width to everything. Save you a whole lot of time. Okay? Well, if I could ever get... No, We've already talked about class width. Okay, write down your relative frequency distribution. Okay, first of all, you got to know what frequency for the class. Well, the frequency for the class is how many people did we have brown eyes a while ago? 5. So that would be the frequency of the class, 5. The frequency of everybody would be 8 because how many people we got in here? 8. And I asked 8 people what color their eyes were. So your relative frequency would be of brown-eyed people, excuse me, of brown-eyed people would be 5 over what? 8 multiplied by 100. That's your relative frequency. So somebody do that in the calculator. 5 divided by 8, and dang old what? So 62.5% of people in here have brown eyes. Would you be willing to say that for the population? Probably. Because brown, I do know, which one is dominant, brown or blue? I think brown is dominant. Naturally, you think brown is going to be more popular than blue. Yes, because it's more dominant. All right. Question. And that's how you do relative frequency. This will be on the test. Relative frequency. How do you find it? Well, you take the number that's in the class, 5 brown-eyed people, divide by the class, 8, multiply by 100. That's what it says right there. And don't worry, we're going to go over homework problems because y'all going to send them in, unless y'all just lazy. Cumulative frequency, I don't spend a lot of time on. It's where you add all the numbers up. It really, I'm not going to spend a lot of class time on that. We'll go over this when we do an example. Yeah, it's already posted. I'm trying to get you through chapter 2 is what I'm trying to do. I haven't seen anything important yet. That's it. That's 2.2. Let's see what's 2.3. Histogram. Do you know the difference between a histogram and a bar chart?
Isn't a bar chart just like
The bar chart and the histogram are both the same thing, except, the bar chart goes up. Well, there's a space between the bars. That's a bar chart. Histograms, they touch. That's it. So a bar chart and a histogram are what? Pretty much the same thing. Let me show you what I'm talking about. Let me go to the next. There we go. That's the histogram. A bar chart, what would be the difference in a bar chart in these two? There'd be a space between this one and this one, space between this one and this one, and a space between this one and this one, and a space between this one and this one. That's a bar chart. This is a histogram. They're actually touching. Say again. Both of these are histograms. A bar chart, there'd be a space between the blocks. Yeah. I was going to see if I could find one, but
it's on the
next page?
section.
Okay. We'll get there.
So could you put qualitative on the history?
Yep. Make sure you know what a normal distribution, skewed left and skewed right, looks like. These two, and uniform. Page 56. This is what these uniform. This is a bell shape because it looks like a what? A bell. This is uniform because there's no variation. We mentioned one variable a while ago that has no variation. What variable is that? In other words, it doesn't vary at all. It stays the same all the time. Huh? Time. Time is uniform distribution. The 10 minutes next year, does it pass the same rate as 10 minutes this year as 10 minutes last year? Yes, there is no change. Uniform distribution would be time. Normal distribution would be like grades in a class. Skewed left would be a classroom where the teacher is unbearably difficult. The class is unbearably difficult. In other words, they hate each other. The class hates the teacher hates the class, and the class is difficult. So chances are everybody's going to what? And that is skewed right. It's always the opposite. All your data is on the failing side, so it's skewed right. That means it needs to go to the right. Skewed right means it needs to go to the right. What about right here? The brown. That's a teacher that gives you 1 or 2 questions for the test, and the questions are, is it a pretty day outside? When's your birthday? And what's 2 plus 2? What would that do to the grades? And that would be skewed left. So are either one of these valid? No. Usually your validity falls in the normal distribution or the uniform distribution. Validity will not fall in the skewed left or skewed right because it's not a valid test. Either it's inflating the grades or you're trying to kick them while they're down. One of the two. It's an extreme. This is an extreme and this is an extreme. Measured against this, which is normal distribution. Make sure you know those pictures. Not exactly these pictures, but the shape. Okay? That's page 56. Yep, thank you. Just tell me where we at. Okay, this is where we get into correlation. So we're going to start with correlation when y'all come back next week. Okay, let me call the roll and talk about what y'all need to do before next week. Because I need to tell the online class that too. Warren, there's only got 8 people here today. $120, y'all are section 12, right? Let's see who we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 4 people missing. All right, Miss Swinger is here. I'm gonna try to remember y'all. No, Miss Swinger's here. Mr. Bright is not here. I'm trying to see who's okay. Miss Cowart's here. Miss Josie is here. That's about all I can remember today. Okay, long. Okay. So I've got 1, 2. So I only need 1 more that ain't here. Are you a Dremmy? How you say it? Adarimi? I tried. Remy? I hadn't heard that name since I was little. There was a guy that lived in our community. His name was Remy. That's neat. Okay, Remy. I can remember that. All right, but somebody still is not here. Brock? That's it. Let's check. Cowart's here. Dyer? Huh? Okay, Dyer? Jones? Evidently it's Jones. Okay. Josie's here. Josie. Long is not here. Oriana, you're in the back. Putnam, Richardson, and Swingers. Okay. Okay, now what I need y'all to do for homework. How many of you are on My Labs Plus? Okay, you need to get on My Labs Plus. Those 2 or 3 that are not, get on there. There's a 21-day grace period, so you can get on and start doing chapter 1 and chapter 2 homework. What are you supposed to be reading? You're supposed to be reading chapter 1, 1.1 through 1.4, 2.1 through 2.4. We've almost covered all of chapter 1 and 2. We've got 2 more sections we'll go over Tuesday, and then we'll be ready to go into chapter 3, and that's where we're going to spend most of our time next week on chapter 3 doing math problems. And 80% of your test is going to come from chapter 3 next week. Yeah, right now I want you to just finishing up chapter 1 and chapter 2. If there's a question, Ms. Cowart, I know you sent me a question. We'll cover it probably Tuesday. Get what? Okay. So, get on My Labs Plus, read chapters 1 and 2, get the homework done for chapters 1 and 2, and if you want me to slow down and go over anything, what do you need to send me? Ask my instructor. Other than that, make sure you get a notebook and make sure you bring pencils to class. Y'all have a good weekend.